And this is a very simple topic. So the reason why I'm saying it's very simple is because it just involves the normal addition, subtraction, and multiplication of numbers. So if you know how to add numbers, how to subtract, how to multiply, then you know all the matrices. It's just that those matrices that you use are matrices with the first order. They are one by one matrices. Yeah. So the way you multiply them, the way you subtract them, the way you add them, that's the way you add all the matrices. So I think we can begin. So what is a matrix? By definition, a matrix is a rectangular array of numbers. Those numbers that are found in the matrix are called the entries or elements of the matrix. So these elements are enclosed in these brackets, these types of brackets. Yeah. So they're enclosed in the brackets. Okay, so having known the definition of a matrix, so a matrix is just anything that looks like what you're seeing here on the screen with entries in it. So these entries can either be letters or numbers. Yeah. They can also be functions. So we proceed. So let's now look at addition and subtraction of matrices. So when you're adding two matrices, you add them according to their corresponding entries. So let's take a look at this. If, for instance, you've been given this matrix A and the matrix B, and then you've been told to add them. As you can see here, you can see to say when you add these 3 plus -2, this is what is just there. When you add A plus B, meaning you're adding these two matrices. So when you add 3 plus -2, you get your +1 there. When you add -1 plus 1, you get your 0 there. When you add these 2 plus 0, you get your 2 there. So this is why I was saying matrices are very simple because you just add them normally, the way you add and subtract other things. Just that all those numbers that we always use in our daily lives are one by one matrices. Now, these are just advanced in the sense that they are maybe 2 by 1, 2 by 3, 3 by 3, 2 by 2 matrices. So we proceed. So same applies to subtraction. When you're subtracting two matrices, you subtract them according to their corresponding entries. So when you look at these 3 minus -2 is just what you are seeing here. So 3 minus -2, you add these 3, you subtract this -2 from that 3. It's just the same as writing 3 minus -2. This is what you are seeing here. I mean, when you add them, you get your 5 there. So adding and subtracting of matrices is straightforward in the sense that you just add them directly, the way you add every other number. But just make sure that you take care of the corresponding entries. Make sure that if you are adding an entry here, maybe which is this entry according to row and column, following the rows and columns, this entry is in the second column and then it's in the first row. So meaning if you're adding this -1 to a certain matrix, you also have to take care of the rows and the columns, meaning it's just the corresponding entries in short. So meaning this one, if it's to be subtracted or if it's to be added, you add it with this one here. So when you add the 2, you get your answer to be -2 because you are subtracting -1. You're subtracting 1 from -1, which will give you negative 2. I hope everything is clear. So we proceed. So for instance, here we can see there are questions here. Though I've not talked about multiplication and division of matrices, but still more, I can teach them through these same examples. So yeah, there are a lot of things that we need to we can look at on matrices, like their definitions, types of matrices, but all those, yeah, they are important at some level of education, but I don't think they are examinable. I'm not sure. I don't think. But if you really need them, you can just go through the slide that Mr. Matindi gave me, the definitions of matrices and the types of matrices. They are there. But we'll look at just important things since you are going to be writing your mock very soon. So I'm just targeting very important things. Okay. So when you are adding these two matrices, let's say, okay, let's take for instance, we want to solve this first question here. When you look at these two here, this two is called a scalar. So a scalar, yeah, a scalar, when you're multiplying it with a particular matrix, you simply multiply it with all the elements in that matrix. So, for instance, you have your A here. Let me write A here. A is 1, negative 1, and then you have 2, you have negative 4, you have 4, and then you have 3 there, you have 2, negative 2, and then you have negative 3. So, we are subtracting these 2, and then the C that we have here is 0, 2, 1, 3, 0, negative 3, then you have 0 there, 1, and 7. So here what you need to do first, you need to deal with this scalar. You first multiply it with all the elements in all the entries in this matrix. So when you multiply them, you're going to have, let me just write it down here. So you're going to have something like this. You're going to have 2 times 0 there, you get your 0. And then 2 times 2, you get 4. Then this 2 times 1 there, you get 2. 2 times 3, you get 6. 2 times 0, 0. 2 times 1, you get 2. 2 times 7, you're getting 14. Then 2 times negative 3, you get your negative 6. Then you 2 times 0, you get your 0 there. So after multiplying the scalar with the entries of the matrix, now you can subtract or add them. 4, 2, you have negative 1, 4, negative 2, you have negative 3, you have 3, and then you have 2. So what you do here now is just a matter of subtracting them according to their corresponding entries. So this one is corresponding with this first entry here, 1 is corresponding to this 0. So I'm going to say 1 minus 0. So 1 minus 0, you get your answer to be, 1 minus 0, you get your answer to be 1. Then negative 4 minus 4, you get your answer to be negative 8. And then 2 minus 2, you get your answer to be 0. Then you move on to the next row. This is negative 1 minus 2, you get your negative 3 there. Move on to this one, 4 minus 0, you get your 4. negative 2 minus 6, you get to negative 8. And then 2 minus 14, you get negative 12. And then 3 minus 6, 3 minus negative 6, you get your, 3 minus negative 6, you get 9. Then negative 3 minus 0, you get negative 3. So this is the solution for the first question then. This is how you solve, and this is how you subtract matrices. So since we have done this one, let us also see how you multiply the matrices now. How do you multiply the matrices? So we move on. So we've been given A to be 1, negative 1, and then 2. I'm actually multiplying, I'm answering the second part here, which is A times B. A times B, so negative 1, and then you are going to have negative 4. You're going to have 4 there, that is 3. And then you have 2, negative 2, then you have negative 3 there. So we're multiplying this with B, which is 1, negative 3, and then you have 2 this side, you have 2. So what you should put in mind is that when multiplying matrices, you multiply them with a rule called the row by column rule. It's row by column. And then it's also important to know which ones are rows and which ones are columns. So rows are these which are moving from left to right. These are rows. And then columns are moving from up there, coming down. That is the way it is. So when we're multiplying matrices, we multiply them with a rule called row by column rule. So we can start. Let me just write here, or just here. I think it will. Let's hope it's going to fit. So I'm going to multiply this 1 times 1 there. I'm going to have 1, and then I'll add it to this negative 4 times 2. So 1 times 1, I get 1. Negative 4 times 2, I'm getting negative 8. Then this 2 times 3, I'm multiplying this first row with that first column to get the first number there. So this 2 times 3, I'm getting positive 6. So I move to the next row. So when I move to the second row here, it means that the numbers that I'm going to start answering are going to be in the, is the number that I'm going to find is going to be on the second row. So I move there. So negative 1 times 1, I'm getting negative 1. And then 4 times 2, I'm getting 8. 4 times 2, I'm getting 8. And then negative 2 times 3, I'm getting negative 6. I move on to the last row. So this 2 times 1, I'm getting 2. And then 3 times 2 to be positive 6. Then negative 3 times 3, I'm getting 9. There's 6 there. And then there's negative 9 there. So I move on to the next column. So when I move on to the next column, it means that I'll also move to the next column here, which is this column there. So I'll move on. So meaning I'll be multiplying the rows of this matrix to the next column there. So I begin. So negative 4 times 3, negative 4 times 3, negative 4 times negative 3, I'm getting 12. And then, oh, wait. Let me do this. Supposed to be 1 times -3. I'll get -3. And then -4 times, -4 times 1, I'm getting -4. And then this 2 times 1 there, I'm getting 2. So you multiply that row with the second column. And then I go to the second row, so meaning I'm going to move to the next row here as well. So this is going to be -1 times -3. I'm getting +3. And then 4 times 1, I'm getting +4. Then -2 times 1 there, I'm getting -2. I move on to the last row, so meaning I'm also going to move to the last row here. So this is going to be 2 times -3. I'm getting -6 here. And then this 3 times 1, I'll get +3. And then this -3 times, so this -3 times 1, I'm getting -3 there. So I'll now move on to the last column, meaning even here, I'm moving to the last column here. So I'll be multiplying all the rows of this matrix to the last column there. So I start. So 1 times 2, I'm getting 2. And then -4 times 5, I'm getting -20. And then this 2 times -2, I'm getting -4. This -2, sorry, I move on to the next row here. So it's going to be -1 times 2, I'm getting -2. 4 times 5, that's 20. And then this -2 times -2, I'm getting +4. So this 2 times 2 there, I've moved to the last row. 2 times 2, I'll get 4 there. And then 3 times 5, I'm getting 15. And then -3 times -2, that's positive. That's positive 6. So I just have now to simplify this. After simplifying this, the answer that I'm going to get is the matrix that I need. So the first one there, 1 minus 8 is -7, and then plus 7, or plus 6, sorry, plus 6 gives -1. So my first entry there is -1. And then this -1 plus 8 is 7. And then 7 minus 6, I'm getting 1 there. 2 plus 6 is 8. 8 minus 9 is -1. So this -3 minus 4 is -7 plus 2 gives me -5. 3 plus 4 is 7 minus 2, +5. -6 plus 3 minus 3. 3 minus 3 is 0, so this will just remain -6. So 2 minus 20 is equal to -18. -18 minus 4, this gives me -22. Since -2 plus 20, I'm getting 18. 18 plus 4 gives me 22. And then move on to the last column, to the last row column here, the last part here. So this is 4 plus 15, that is 19. And then 19 plus 6 gives 25. So this is the solution for the second part there. This is the solution for the second part. So A times B, so A times B is giving us that. So this is how you multiply matrices. So here, for B times A, you just multiply it the way you just swap. This goes that side, and then this comes this side. You swap them, and then multiply them the way we have done this question. So here, it's also straightforward. You multiply this scalar 2 with B. You multiply this 2 times B, and then also multiply 3 times C, and then you subtract them. You follow BODMAS, by the way. This also follows BODMAS. So meaning you're going to start first by dealing with what's in the brackets. You first deal with everything in the brackets. So you deal with this first. This is going to be 2B minus 3C. And then after that, your final answer that you're going to get, you come and multiply it with A. Then you find the answer. So for matrices, you should just be careful multiplying and adding, because since we're dealing with a lot of numbers, a lot of errors come about. A lot of people make mistakes in just multiplying these simple numbers. Yeah. Even 5 here, it's just the same. You multiply this AB, and then since you already have we already have our AB here. So meaning after multiplying AB, you get this. You just have to come and add your B there. So meaning you're just adding B this side for 5. You just put your B this side and then find the answer. Then,
Mr. Teddy,
yeah.
Can you recheck on the what's this, on the third column, then on the second row? Second row there where there's -2.
Okay, let me try to check. So here, this is -1 times 2 gives -2, and then 4 times 5 is giving us 20, and then -2 times -2 is giving us 4. I think it's just okay. I think it's just okay.
Oh, but okay, Mr. Teddy.
Okay.
Oh, but there you are using 2, 3, -3 what's this column to, I mean row, to multiply against that's -3, 1, -3, 1 and 1 what's this column, right? Which one were you using?
I was using this second row, multiplying it with the last column to get this.
Oh, but how come you're getting that? Like -1 times -3?
No, -1 times
Then
2
4
here. -1 times 2, I'm getting -2. And then this 4 times this 5, I'm getting 20. And then -2 times -2, you get +4.
Oh, okay.
Yeah. All right. So thank you very much for that question. Then we move on. Before maybe we proceed, let me just show you how to find a transpose. Though I've made it as a subtopic at some point, I'll show you properly, but let me show you how to find B transpose. So if your B is here, which is 1, this is your B. This is 1, 2, and then 3. You have -3, you have 1, 1, and then this is All right, thank you very much. So I was saying the transpose of a matrix is just defined as okay. It's just you just supposed to make all the columns to be rows. You just change all the rows into columns or all the columns into rows. You still get the same answer. So I was saying this first column here, 1, 2, 3. I've made it my first row there. 1, 2, 3. So the second column, negative 3, 1, 1, I'm putting it here, negative 3, 1, 1. Then the last column there, 2, 5, negative 2, I'm putting it as my last row there. 2, 5, negative 2. So if you want to prove whether your transpose is correct or wrong, you look at the leading diagonal. The leading diagonal is this one here. This is the leading diagonal. The leading diagonal of a transpose of a particular matrix is supposed to be the same as the leading diagonal of that matrix. So if you find or if you discover that these two diagonals are different, just know that you've made a mistake somewhere. So this is how you check whether your transpose is correct or wrong. So this is B transpose. So in short, you just change all the rows into columns. That's all. That's the simplest definition of a transpose. Let's move, let's proceed. So let's take a look at two very important types of matrices that we're going to use maybe from now on up to the end of this lesson. I've just picked two out of those matrices that were given in the module. So first look at the identity matrix. So identity matrix is just like, it's just a 1. In these normal numbers, in a 1 by 1 matrix, it's just 1. So when you multiply this 1 times any number, let's take for instance, you multiply this 1 times 2, you still get the same answer 2. So meaning this one is an identity matrix of a 1 by 1 matrix. Now, if you're having a 2 by 2 matrix or a matrix with the order 2, the identity matrix is this one. So when you multiply this, this ID matrix with any given matrix, A, B, as long as it's also in the order 2, C, D, you still get the same answer. You still get the same matrix, which is A, B, C, D. So when you multiply this identity matrix with any matrix, you still get the same matrix. So this identity matrix is just a special one in matrices. This is what is being talked about here. When you check, when you multiply B times I, you still get B. And it's just the same as multiplying I times B, you get the same B. And then the transpose of a matrix, this is the one I was saying, I'll put it as a subtopic alone. So the transpose of a matrix, like I said, you just change all the rows, you take them into columns, then change all the columns into rows, it's just the same. So as you can see, the leading diagonal here is just the same as the leading diagonal there. They are not different. Same applies to this. The leading diagonal is 1, is this one here. Same applies to that. So in short, you just change all your columns into rows. So this 1, that 1. So 1, negative 4, you see 1, negative 4 there. 2, 5, you see 2, 5 there. 3, 0, you see 3, 0. Like that. So these are the most important matrices that you should put in mind. I hope there's no question here so that we proceed. Okay, let's take a look at this is question 2 and question 3 from your tutorial sheet. So as you can see here, since we've talked about transposes of the matrix, it's just straightforward now. You just change all the rows into columns. You take them into columns there. And then when you switch them again, so meaning the answer here, the answer for the first question here is like you're transposing the same matrix 2 times. So the answer for A is just the same as this one here. When you transpose a matrix 2 times, you're supposed to get back to the first matrix that you had. And then here, you're just multiplying A times B, and then you transpose the final answer. Here, you first transpose B, you also transpose you also transpose A, and then you multiply the 2. Once you multiply the 2, you get your answer. Same applies to this part. You transpose A, transpose B, and then multiply them. You get to your answer. Here you are adding the 2. You add this A, and then you add it to B, and then the final answer that you get, you transpose it. And this is not the same as this. They are not the same. So for this one, you first have to add A and B and then transpose them, and transpose the final answer. But for this one, you transpose A, you also transpose B, and then you add the 2 answers. Okay, let's proceed. So let us now look at this one. This question was just testing us on equal matrices. So when 2 matrices are equal, they should have all the entries in them the same. So if you have A, you have B, you have C, you have D as your first matrix here. For the equal matrix to this matrix that I've put here is just the same matrix again. There isn't supposed to be any difference. Everything is supposed to be the same. Nothing should be different. So if the first entry here is A, meaning the first entry in the equal matrix to this is also supposed to be A. So as you can see here, this 3 is just the same as that 3. This 0 is just the same as that 0. You can see, so if these two are the same, it means that even the remaining ones are the same, which implies that this x plus 2 is just the same as that 3. And then this y plus 3 is just the same as that 6. So meaning we're going to equate this. So this, we said x plus 2 will be just the same as 3. So meaning for us to find x, we need to just take this 2 to the other side of the equal sign to be 3 minus 2, which gives us 1. Same applies to y plus 3. Y plus 3 is just the same as 6. So y plus 3 is just the same as 6. So when you simplify this, you're going to have, so when you simplify that, you're going to have 6 minus 3, meaning your y there is going to be 3. So these are the values of x and y they wanted. I don't know, they were talking about z, which is not even there. This was just an error. So we proceed. You also have this. They're saying, given that 3, 1, negative 1a, when you multiply it with 1, 2, 0, 1, you get this. Find the values of a and b. So this question is also straightforward, in the sense that you just have to multiply the 2 matrices, and we've learned how to multiply matrices. Straightforward. Let me just write them here. You multiply matrices according to the rule, which is the row by column rule. So this is what you're going to have here. So, and then this is going to be B, and then 7, 4, -1. So here what you do is, you multiply this 3 times 1 there, you get your 3, and then plus 1 times 0, you get your 0. So you're going to have 3 plus 0 there. Then this 3 times 2, you get 6. And then 1 times 1, you get positive 1. And then you move on to the next row, which will be -1 times 1, you get your -1. And then this A times 0, you get your 0. So you're going to have a 0 there. And then this -1 times 2, -1 times 2 is -2. Then this A times 1, you get your A there. Then you put them in brackets like that. Then this is equal to, so these are also equal matrices. These are also equal matrices. Okay. So I'm going to add this 3 plus 0, I'm getting 3, -1 plus 0, I'm getting -1, 6 plus 1, 7, -2 plus A, I'll write it as that, -2 plus A. So now, how do I know that these are equal matrices? You look at the entries that you have there. Are there some common entries which have the same exact, are there some entries which are the same? You ask yourself. So when you look at this -1 there, it's corresponding to that -1 there, meaning they are the same. So that's the first thing that is telling us to say these two matrices are equal. You look at this 7 there and that 7 there, it's just the same. So meaning these two matrices are equal. So if these two elements are equal, it means that also this 3 and this B are equal. So this B is just equal to 3. And then how do I find A? So I'm going to find A by also equating this -2 plus A to its corresponding entry in this other matrix, which is 2 plus A being equal to 4. So to find A, I'm going to take this -2 to the other side of the equal sign. So this will be 4 plus 2, which gives 4 plus 2 is giving me 6. So meaning the values of A and B are as follows. So A is equal to 6, and then B is equal to 3. So these are the values of A and B that they wanted. So question 3 is also testing you on equal matrices. But since we need to finish this first, you answer this one and try to submit. I see how you're going to solve it, because you've been given this expression, which implies that you first have to multiply A and B, which are these here. You multiply A and B, you write your answer there, and then you equate it to the difference between A and B. So the difference between A and B is just you subtracting B from A. So meaning you're going to subtract this B from that A, you write your answer there, and then pick corresponding entries, and then find the values of P and Q. Let's proceed. So let's look at determinants of matrices. So for instance, when you've been given a matrix like this one, a 2x2 matrix, which is like this one, if this is your A, if you want to find the determinant of A, you just multiply this first entry with that, and then minus this and that. That's the way it is. So you multiply A11 times A22 minus A21 times A12. Then you get your answer. So what I'm trying to say is this. And by the way, the determinant can be denoted by this here, DET, means determinant of A, or this, which is just A in absolute values. That's the determinant. That's how you can denote a determinant. So, yeah, this is how you find, this is just what I was talking about previously. Okay, so we move on, we proceed. So let's look at this example here. It's a question in your tutorial sheet, which says find the determinant of each given matrices. Yeah, I removed the other matrices. Well, first we need to learn the 3 by 3 and any matrix that has the order above 3. That's when I'm going to answer those questions. So let us first look at this one, which is a 2 by 2 matrix. So given this matrix here, then you've been asked to find the determinant of A. So the determinant of A is just found by multiplying these 2 times -2 there. 2 times -2, you will get your answer to be -4. And then you write this minus in advance before multiplying the next diagonal. So you write this minus in advance. So this minus, and then this will be 4 times 3. So 4 times 3 is 12. You put your 12 there. So the answer that you get there will be -16 as your determinant. So your determinant is -16. And one may be wondering to say, why do we always put this minus here? Why is it there? So this minus there is, let me show you something here so that maybe you understand it better when we're going to look at it where we're going. So this minus here comes from this matrix of cofactors, which is, it has a positive, it has a minus, it has a minus there, and it has a positive. So this number here, when finding the determinant, has to be multiplied with a -1. All right, I think you understand better when you proceed. So in other words again, what we have just found is a minor. So this -16, despite it being a determinant, since despite it being a determinant, it's also called a minor. You understand better where we're going. Let's proceed. So let's look at finding the determinant of a 3 by 3 matrix. Yeah, so for a 3 by 3 matrix, you need to know what are called minors and what are called cofactors. Without you knowing these, it will be difficult for you to find the determinant. So what are minors? So a minor is just a determinant. It's just a determinant of a 2 by 2 matrix. So let's say, for instance, you've been asked to find the minor. For this M stands for minor. So minor of an entry which is found on row number 2 and column number 3. So meaning they are saying you are moving in the second row and the third column. What you should put in mind is that this 23 you are seeing here is not 23, it's 2 by 3. Sometimes they denote it as M by N. No, sorry, it should be I times J, not M by N. Yeah, they will denote it sometimes as I, J. So that is it. And then, so the question is saying we find the minor of when we delete the second row and we also delete the third column. So when we delete the second row and the third column here, what is the minor of this matrix? So M23, M23 or M23 says the same, is going to be equal to all right. The problem with network here. So proceed. So this is what I'm trying to explain here. So to find the minor of this, you delete the second row and the first and the third column there. So meaning the remaining numbers are the ones that you're going to use to find the determinant. So meaning we're going to multiply 1 times 8 there, you get 8, and you write the minus in advance, and then multiply 7 times 2, you get 14. So the minor there will be 8 minus 14. So 8 minus 14, you get negative 6. So now, if this is your minor, negative 6 is your minor, it means that your cofactor is going to be, so the cofactor of 2, 3 is going to be this same negative 6, you multiply it with negative 1, but this negative 1 should be raised to the sum of these 2 and 3. So when you add 2 plus 3, you get 5. So a negative number to the power 5, oh sorry, negative 1 to the power 5, you get a negative 1 again. So that negative 1, you multiply it with negative 6, you get your answer to be positive 6. Yes, you get your answer to be positive 6. So in other ways, this is what I said I'm going to show you at some point. You have a plus there, minus, plus, minus, plus, minus, plus, minus, plus. So this minus here is the one that will just multiply to find the cofactors. You remember I said this is a matrix of cofactors. So to find the cofactor that is here, when you look at this, where these two lines are meeting here, they are meeting at this point. So according to this matrix of cofactors, they are meeting at that point. So this point where they are meeting, you take the sign that is there and multiply it to the minor. So this minus, I'm multiplying it to this negative 6, and then I get positive 6. So as I get that positive 6, that is then my cofactor. So if you want, you can go on using this, or if you want, you can just be raising this negative 1 to the power of the sum of what you've been given. If you've been given 2 and 3, meaning you just have to add this 2 plus 3, the answer that you get, you raise negative 1 to that answer. And then the final answer you get, you multiply it with the minor that you found. I hope it's clear. So this is what I was talking about. So you delete the second row and the third column, and then you get your answer to be negative 6. Yeah, you get your answer to be negative 6, and then this negative 6, you multiply it with the negative there, you get your cofactor. Yeah, but for the second question, this is the second question where they deleted the third row and the first column. Then what they remained with is what they used to find the minor there. Their minor was negative 3. So now finding the cofactors, this is what you're going to have.
Mr. Teddy.
Okay.
Mr. Teddy.
Yeah.
Can you just go back where you illustrated the signs of a 3x3 matrix? Well, yeah, or that one in, yeah.
Okay. This is how it looks. So you start with a positive, minus, positive, minus, positive, minus. and then positive, minus, positive. It goes on. You can even illustrate, you can even make something for a 4 by 4, a 10 by 10, but you just make sure that you start with a positive here. Okay. Is it clear? We can proceed?
Yes.
All right.
Yes.
Okay. So cofactors, yeah, using the same matrix there to find the cofactor of 2 and 3, just we first find the minor. We found the minor to be -6, and then to find the cofactor of that, you raise your -1 to that power, and then you multiply it with -6, you get your +6. Same applies to this. We found the minor to be -3, and then the cofactor, there it is. Yeah. I think there was a mistake here. I think, yeah, there was a mistake because this -3 multiplied by +1 is supposed to give you -3. When you remember this, which I drew here, it's like this. So meaning here, when you cancel this and this, the sign that you are going to have here where these two lines are meeting is a positive. So when you multiply this positive times -3, you still remain with a -3. Yeah. So it's just as simple as that. So we proceed. So sometimes you may be asked to find the minors and cofactors of a matrix which is not a 3 by 3 matrix, but a matrix with the order greater than 3. So this is what you do the same. They tell you to find the minor of or the minor at the point 3, 3. So meaning you are deleting the third row, you are also deleting the third column. Then the numbers that you're going to remain with are the ones that you use now to find the minor. So the minor, remember what I defined the minor, I said it's just the determinant. So you're going to, the numbers that you remain with are these numbers. We're going to remain with these numbers. These are the numbers that we're going to remain with. So you find the determinant of this. And we know when you're finding the determinant of a 3 by 3 matrix, you multiply this first number here, you multiply the first number there, then open brackets, you multiply this first number with its minor. So the minor of this number is this one, which is, so this is going to be 3 by 4, you get 12, and then 12 minus 2 by 2, you get 4. Then you write your minus. There's a minus when you follow the matrix of cofactors, this one. Yeah, coefficients of cofactors. So when you follow this properly, this is what you're going to observe. So there's a minus here. This is the one that I've put here. Since I'm now supposed to, I'm multiplying this negative with that 4. So I'm going to have -4 there and then open brackets. When I delete, let me do this. Okay, so when I delete this column and this row, oh sorry, not that. When I delete that column and the first row here, the numbers that I'm going to remain with are the ones that are going to make my minor for that 4. So this is 2 times 4 there, I'll get 8. And then this 1 times 2, I'll get negative. So yeah, -1 times 2. It's a determinant that we're finding. which is 2. And then I'll write finally my 1 there. So this one there is a positive. When you look at the cofactor here, the coefficient of this is a positive. So this is the positive that I write there. Then I'll put 1 there, open brackets. So I'll cancel this one and that column. The remaining numbers are the ones that I'll use to find the determinant. So 2 times 2 there, I'm going to get 4. And then 1 times 3, I'm going to get, so minus 1 times 3, I'm going to get 3. So this is going to be 5, open brackets, 12 minus 4, I'm going to get 8. And then this is negative 4. 4 times negative, 8 minus 2, I'm getting 6. And then this is plus 4 minus 3, I'm getting 1. 1 times 1, I'm getting 1. So here it's just a matter of finding simplifying it. So 5 times 8, I'm getting 40. Then minus 4 times 6, that is 24. Then plus 1. So what you're going to have here is 41 minus 24. You're going to get your answer to be 17. So this is the minor on row number 3 and column number 3. This is the minor 17. But how do you find the cofactor of this same row number 3 and column number 3? So the cofactor now is going to be found by doing this. 17. So if you want, you can, this matrix is a 4 by 4 matrix. So you can just extend this if you want. So we're going to have a plus, also a minus, and then a plus there, and minus. Then you also have a plus there, minus, plus, minus, if you want. But if you want, you can use the formula that I'm going to show you here. So when you check 3 by 3, so 3, you delete the row number 3 like that, and you also delete the column number 3. You take the sign which is there. So the sign there is positive. So this positive is the one that you multiply with the 17. So meaning the cofactor will be just 17 like this. So it will be positive 17. Now,
Mr. Teddy.
Yeah.
Yeah, I'm a bit behind on where you were which numbers you are subtracting, where you got them from, like 12 minus 4, 8 minus 2, 4 minus 3. But I know where. Oh, yeah, but I've understood where you've gotten the coefficients, like 5, 4, and 1.
Okay.
Yeah. But just where were you getting the numbers?
All right. Let me start with the last one here, where I got 4 and 4 minus 3. Or let me just restart maybe to help you. So where I got 12 minus 4 is from here. So if I'm getting 5, I'm going to delete the row where 5 is. I'll delete it. I'm also going to delete, I'll delete the column where 5 is, and I'll also delete the row where column is. Where 5 is, sorry. Yeah, I'm going to delete the row where 5 is, and I'm also going to delete the column where 5 is. The remaining numbers that I'm going to remain with here are the ones that I'm going to use. So I'm going to find the determinant of the remaining numbers. So the determinant of these remaining numbers here, which is 3, 2, 2, 4, is you multiply 3 times 4, you get this 12, and then minus 2 times 2, you get that 4. Same applies to the next one now. The next one is also, I'm going to do the same on the next one. I'm going to do the same on the next one. I'm going to, if I'm using 4 now, on the next one I'm using 4. So meaning I'm going to delete the row where 4 is. I'll also delete the column where 4 is. And then the remaining numbers are the ones that I'm going to use to find the determinant. So here the determinant will be 2 times 4, which gives me 8, and then minus 1 times 2. This is the 2 you are seeing here. And then same applies to the last part here. When I'm using this one here, when I'm using the one here, means that I'm going to delete the column where 1 is. I'll also delete the column where, the row where this one is. So meaning the remaining numbers that I'm going to have here are the ones that I'm going to use to find the determinant. So this is going to be 2 times 2, which will give me this 4 there, and then minus 1 times 3. I hope you've gotten it. All right, I think we can now proceed. So I was saying to find the cofactor for this number here, which is 3, we are going to multiply it with -1, and then we raise it to the sum of these numbers that have been given here, which is 3 and 3. So the sum of 3 and 3 will be 3 plus 3. So this is going to be 17. Then this -1 raised to power 3 plus 3, which gives 6. So -1 raised to power 6 will be +1. Then +1 times 17, you still get the same 17. So you choose which one is going to be easier for you. You can either use this method that I've shown you here, or just draw this matrix of coefficients of cofactors. And then you apply it, you still get the answer correct. So yeah, it's a lesson. Yeah. So this is what I was talking about. Yeah. So now, having learned how to find the minors and the cofactors, I think it's now easier for us to find the determinants of any given matrix. So the determinant of this first matrix here, we found it in the previous lesson. So in the previous slide, let me just go back a bit. Yeah, it's here. We found it to be 16. This is the one I was saying. I've just picked it alone, and then the remaining ones we are going to find them as we proceed. So we continue. So let us now try to find the determinant, maybe of this matrix here. This one. So when you're finding the determinant, sometimes it's advisable for you to pick a row or a column that has a lot of number of zeros. Okay. Let us try to find maybe the determinant of this. But of course, since we have one row which has zeros everywhere, you can even guess here to say the determinant is going to be 0. Why? Because I know that if definitely when I pick this row if I decide to use this row to find the determinant, I'm going to get everything to be zeros. So zeros times zeros, I'll still get the answer 0. So for this last question here, you can try it on your spare time and make sure that you find the determinant 0. Let's find the determinant for this one. So the determinant for this one, okay, I'll decide to use this column because I know that it has a 0 somewhere there. Or maybe for simplicity's sake, let me just continue using the same row that I've always been using. instead of maybe we might end up confusing some people here. So let me just use the first row that I've always been using here. So to find the determinant of this matrix B, we're going to have this. So this is going to be 1. We write our 1 there. So I'll write this one here, this one you're seeing here. I'll write it there. And then I'm going to open brackets. So I said you delete the column where this one is and the row where this one is. Then you use the remaining numbers to find the determinant. So we're going to have -2 times -1. Your answer will be 2. And then minus, this is going to be 5 times 3. So 5 times 3, you get 15. So 5 times 3, you get 15. So we proceed. We move on to 2. So when getting these 2, remember the matrix of cofactors. It has a negative. It is positive, negative, positive, negative, positive, negative. This is the way it is, negative, yeah, positive. So meaning this 2 has a negative. So meaning we're going to, instead of just maybe picking just 2, we pick -2, not 2. The negative there is invisible, so you put negative, then you put your 2 there, and then open brackets. So we delete the column where this 2 is, and the row where that 2 is. So the remaining numbers are the ones that we're going to use to find the determinant. So this is going to be 4 times -1, you get -4, and then 0 times 3, you get your 0. And then we proceed. So we pick now 3. So 3 is positive, 3. Yeah, 3 is positive there. So you open brackets, and then you're going to delete this and also delete that. So the remaining numbers are 4, -2, 0, and 5. So just multiply 4 times 5, you get your 20. And then minus 0 times -1, you get your 0. So the determinant of B will be 1. So this is 2 minus 15, you get -13. Times 1, you still get -13. And then we move on. This is -4 plus 0, it's -4 times -2, you get your +8. And then you move on here. This is going to be 3 times 20 minus 0 is 20. 20 times 3 to be 60. So you're going to have your 60 there. So here it's just the same as saying 68 minus 13. So 68 minus 13, you get your answer to be 55. So the determinant of B is 55. Yes, so the determinant of B is 55. So this is how you find determinants. It's not difficult. So I'm just remaining with about, I'm sure this is 7 minutes, because the sessions, today the session was not ending at 40 minutes. It was supposed to end at 40 minutes, but since I just re-downloaded the Zoom, meaning I have free trials that I'm going to be using for hours. So this is what we're going to get as our determinant. Let's see what's next. See, maybe we can do 2 or things before we close the meeting. So this one is just also testing you on how to find the determinants. Yeah, and then for such questions, when they tell you to verify, to prove, or to show, sometimes it's just the same as you have already been given the answer, and then you just need to show that this is the answer, or this answer is true. So how do you do that? According to this question, you've been given this A, the matrix A and the matrix B. then you've been told to verify whether the determinant of A is equal to the determinant of A transpose. So you first find the determinant of A. When you find the determinant of A, you write it, and you also find first you find the transpose of A. Remember what we talked about previously. We said the transpose of A is just by, you find it by just changing all the rows into columns. Yeah. So you find the transpose of A, you write it, and then find the determinant of this transpose. The determinant of this transpose. You write it. You are going to discover that these two answers are going to be the same. The determinant of A and the determinant of each transpose is always the same. It's always equal. There's no difference. Same applies to the first question, to the second question here. The multiplication, when you multiply A and B, you get your answer. So when you multiply A and B, you get your matrix there, and then find the determinant of this. So find the determinant of A and B. You find your determinant of A and B. So you're going to discover that the determinant of the multiplication of A and B will just be the same as the determinant of A multiplied by the determinant of B. So in this case, what you need to do for the second part, you need to find the determinant of A separately. You find the determinant of A separately. And then you also find the determinant of B separately. You also find the determinant of B separately. And then multiply the determinant of A and the determinant of B. So when you multiply these two, you are supposed to get the determinant of AB. So if these two answers are different, just know that you have made a mistake somewhere. So if this answer that you found here is going to be different with this answer here, just know to say what you have made a mistake somewhere. It even gives you assurance to say you have gotten it wrong. You need to go and check your solutions to check whether it's correct or wrong. So these questions are just as simple as this. All right, it's even almost time up. So this is just the same, yeah. So here, instead of D, this was supposed to be, oh yeah, instead of C here, no, wait, instead of B here, this was supposed to be D. So supposed to be DS. So you can also show this, and you guys, what you should know is that I've been putting links in these lecture slides. So if you are stranded when going through the same lecture slides, you're stranded on any question, you are solving it and then you are stranded, you can just click on that link. It will redirect you to my YouTube page, and then you see the solutions for that particular question. It really helps. And then, so here you just multiply CD and also multiply DC, which will give you 0. So here they're saying find the matrix D for which CD and DC is equal to 0. At first they said show that the matrix is singular. A singular matrix, let me just talk about a singular matrix and then we end the chapter. We end the lesson. We'll come and proceed maybe tomorrow if you guys are going to allow me to teach you tomorrow so that we finish matrices. Because we're just going to remain with equations of matrices. And yeah, equations and the inverse of a matrix. So a singular matrix is a matrix which has a determinant equal to 0. That's about a singular matrix. So if they tell you to say, show that this matrix is singular, they are just telling you to say, find the determinant of this, and the determinant of this matrix is supposed to be 0. So meaning after finding the determinant of this, and then you get something that is not a 0, just know that you've made a mistake somewhere. because they've already told you to say this matrix is singular. Now show them to say it's singular, meaning you just have to find the determinant of this matrix, and it is supposed to give you 0. Yeah. So that's it. Anyway, you can. I'm going to put links in this slide before sending, so that you can see how I solved some of these questions. If you have any questions, so you guys, let's discuss in the group to see whether we can meet tomorrow to finish the matrices, so that at least you remain with Wednesday, and probably, or I mean, you remain with Wednesdays to go through what we've learned, so that you come and write your mock. Yeah. So I'm ending the meeting if you don't have any questions. In short, if you have any questions, you can ask before I end the meeting. Okay, seems like there are no questions. So I'm ending the meeting. Let's discuss what time we can meet tomorrow to have our last lesson on matrices.